We're going to look at an inverse function using function notation. Okay. Do you recall how they normally represent an inverse function when we have function notation?
F to the power of negative.
Yeah, so if they tell us this, they write it with these symbols. What they're asking for is what is the inverse of this function equal to? And usually the easiest way to find the inverse of the function is actually take it out of function notation and to put it, set it equal to a y value. So we'll take this and we're going to set it equal to y. We'll say y is equal to the exact same function we have up here, 3x minus 4 squared plus 2. Okay. And then the best thing to do is to actually switch the places of the y and the x in the function. Okay. So when we change these two around, okay, that won't actually be the last step, but that'll be our first step in terms of finding the new function. Once we've done that, we'll want to set it equal to y again, because if you notice, when we replaced our f at x, we usually set something equal to y, and that's kind of what we replaced y with, is that f at x function. So when we change these two, we'll now have x is equal to 3y minus 4 plus 2. Okay. Now, the actual function, the way it's written, we normally, again, set it equal to y. So we got to go through that process. So we kind of use a little reverse BEDMAS. This is positive 2. So if I'm going to move it to the other side of the equation, what would it become?
Minus 2.
That's right. So we get negative 2 is equal to 3y minus 4 squared. Do you know what the next step would be in this process?
Divided by 3.
That's right. We'd want to divide both sides by 3. Okay. So we divide both sides by 3. This side simply becomes the value of 1, or it cancels out. Okay. From there we have x minus 2, and what I'm actually going to do is put it in brackets and say times a third. Does this idea make sense to you as being the same as above?
Yeah.
Yeah? Okay. And the reason I'm doing that is because that's how usually a transformation of a function would be written. They usually wouldn't write it like this. They'd separate it. This would be considered like the k value. Okay. Is equal to still our y minus 4 squared. What would the next thing be?
Square root it.
Yeah, we square root both our sides here. On this side, these cancel out, and we're left with the root of 1 over 3, that kind of being our k. Our negative 2, do you guys call that the d value normally? Yeah. Is equal to y minus 4. And what would the last step here be?
4.
That's exactly right. So you end up with the root of a third x minus 2. All of that on the bracket. Then outside of that root, we have plus 4 is equal to y. So the inverse function is equal to 1/3. Let's put that bracket there. X minus 2. I'll try to write this nicely here. All under the square root of, and then plus the value of 4. And this is the inverse of that function, and we can actually quickly show this. Oh, I have a lot of those open. Let's go into Desmos here. Our original function was, I believe, 3x minus 2 squared plus 4. And I'll check that to make sure. Oh, x minus 4 plus 2. Minus 4 plus 2. Okay, so there's our original function. And a function is normally an inverse on the relationship of y equals x. So we've flipped it on this line here, this being like our line of symmetry. If it was a piece of paper, this is where we'd make our fold. Our new function, we said, is the root of 1 over 3 multiplied by x. Let me just double check what it is. X minus 2. And then we said outside the function plus 4. Now, you'll see the bottom of this doesn't show up here. Do you know why the reason for that is?
Because the domain, or the range is restricted.
Well, that is an idea here, but we're talking about functions. Do you remember one of the rules to be a function? Do you know what the vertical line test is? Okay, so in order for something to be a function, you have to be able to run a vertical line through it, and it only touches one point at a time. So, okay, look above. I'm going to take this exact same function, Control C. And remember the very first thing we did is we set it equal to y, and then we changed the position of the x and the y, right? So this purple one went right over that. I'm going to change this to be the y value, and this to be the x value. And lo and behold, it shows both sides. The problem is this is not technically a function, because if I draw a vertical line through it, it hits the function twice. And in order to pass a vertical line test, it can only hit it once. So when we write it the proper way, what happens is it doesn't write the bottom part there. Okay. If we were to put a negative value in front of it, it would kind of flip it on its edge because of a values. But keep that in mind. If you need to graph the function, technically, for it to be a function, we can only kind of draw or graph half this function. The purple one really represents the fold on that line of symmetry there. You can see that if we folded it there, that's how that would be the inverse of the other function. Okay.